talk, Journey to the Center of the Microverse. So we're basically going to be looking at the history that ClearBank, or the journey that ClearBank has gone through, kind of starting from the early initial tech choices right up until kind of today and where we are now, and going through some of the pain points and how that guided us along this path. So first of all, some quick introductions. So I'm Alistair. I'm a software engineer with ClearBank, and I work just in the international payments side of ClearBank at the moment. And talking alongside me is Callum. He's one of our principal engineers, and he works on the UK sterling side of our payments. But one of the first questions you might have really are kind of, who are we? What is ClearBank? So on the slide here, we've got some kind of descriptions, who we are, what we are, why we do this. But to really kind of explain it, kind of what we really do, the way we usually describe it, or often describe it, is that we're building modern back-end banking infrastructure. So ClearBank is actually one of just 5 institutions which are authorized to move money through the Bank of England. So what we're doing is we're providing the kind of base, the platform upon which, you know, the other financial institutions, other fintechs that you may have heard of, we provide the kind of back-end base for them to build and provide their services off. And how do we kind of do this? Well, using a tech stack built on Azure. So here we have a kind of obligatory wall of icons, but ClearBank is built on Azure using all of these kind of cool technologies that it provides. And we are a bank that is entirely in the cloud. And as mentioned, the predominant language that we're writing in is C# on the .NET Core structure, hence kind of why Luke's invited us, as he said. So when ClearBank was starting, what were the initial goals? Where did we really come from? And as I just mentioned, we are a bank that's completely in the cloud. And banking and, you know, the financial industry is a highly regulated industry. So, you know, a bank in the cloud isn't exactly something that makes regulators the most comfortable from a security perspective, possibly. So realistically, when we're starting, the main goals was to demonstrate that this was a viable, secure product, and that we could show proper processes. Part of the regulations actually were that we were extremely limited in the amount of transactions initially that we were allowed to make every day, limited to about 40. And that's kind of quite important to kind of have in mind, because what wasn't part of the initial criteria when designing like the first initial system was actually kind of large volume and scale. It was to show viability and correct process. And I'm glad to be able to say that after some hard work, that goal was achieved. We did obtain our banking license, and we integrated with all the major payment schemes in the UK. So that's BACS, CHAPS, etc. Now, the solution or the service that we had created, the system, was all built around a single solution. This single solution was exposed via an XML API that went down into a centralized single database where all the information for accounts, transactions, customers, all this information was held in one central database. And as it was all kind of centralized, when it came to making changes, all these changes that different people from different teams would be working on would be all rolled up into one and released at once, about quarterly. So not a particularly high turnover, but this system, it worked. It showed that the process worked and was viable, and that we could move forward. We got the PRA approval which was basically the green light to scale into higher volumes, move towards hundreds, thousands, etc. transactions. But with that approval and that green light, we need to start thinking about what's worked for us and really what do we need to change. So one of the first targets that we had was splitting that single centralized system, kind of splitting up that monolithic structure into separate services. Now, at the time that we were considering this, Microsoft was promoting their Service Fabric hosting service, and we decided to go, with some motivation from them, towards Service Fabric and using Service Fabric remoting. At the same time, we wanted to split our teams to reflect this kind of desired software structure, kind of taking inspiration from Conway's law that your software ultimately is very likely to end up looking like the communication structure of your organization. So by splitting the service into multiple services and splitting the teams alongside that, we can define these domains, go towards kind of domain-driven design principles, which also brings us on to splitting the database, that centralized database, splitting it out so each service owns the data that's relevant to it. Another thing that we saw from kind of interactions with our customers, something that they wanted to improve upon, was moving away from an XML API and moving it towards a JSON, which our customers found easier to integrate and onboard with. So these were the kind of decisions that we made kind of after the initial step, the initial system that we had produced. But with all of these things, every decision that you make, every choice has its advantages and it has its disadvantages. And this is no different. So one of the first things that we want to talk about is what we really did gain from this initial shift. And that came out of the way that we structured our teams. So by trying to break down into smaller services, that allowed us to define these bounding contexts, define these domains. These domains could then be passed on to separate teams, as I said, splitting the teams out. And we gave the teams exact ownership of these domains. Now, that means that the team has responsibility, but it also has autonomy. It can self-organize and deploy that domain as it sees fit. Take it in the direction that it wants, that they want. Now, part of this is following or allowing the teams to use a well-documented and kind of automated release process, which also allows for strong auditing of releases. And this is really important because, coming back to what I mentioned before, financial industry, very highly regulated. But by following these processes and using automated releases, we can actually, in this highly automated, this highly regulated environment, we can release at a high cadence still. And this ultimately can lead to a better developer experience because we've got this tighter feedback loop. Developers can see the effects that their changes are having as they make them. Can lead to being able to make smaller, faster changes, which are more manageable. And as we said, giving the teams this autonomy means that they can make their own decisions and actually leverage the expertise that they have inside the team. After all, you hire good developers for their expertise. You want them to be able to apply that in the design. Another thing that came out of splitting our services and kind of helped move towards kind of autonomous teams was tiering the services. So the main reason for this was different services have different priorities as far as what's important to the business. By setting tiering on these services, it means that teams are able to more easily prioritize their work and make sure that the most crucial central workflows remain always in place and don't go down. This is great for the overall system resilience, but it did also highlight certain assumptions or oversights that we had made. We actually saw that, a very simple service that you don't think is particularly important actually is a key dependency to some other critical tier 1 service. And if multiple critical tier 1 services are calling this one what you thought inconsequential service, that inconsequential service suddenly isn't so inconsequential, and you need to maybe reassess that. So that's quite an interesting outcome for us. But having talked about this, I want to point out kind of our main takeaway from where we went with our teams, the key takeaway, and that was a focus on smaller, more autonomous teams, which we found led to kind of happier developers feeling more in control, and ultimately that's going to lead to better code and better services that we have. So I'm going to stop there. I'm going to pass you on to Callum to take you through some more technical decisions.
Thanks, Alistair. So one of the first thing that we mentioned there was a move to service fabric remoting, and obviously moving to that, there was some pros with this. So it was easy to implement, it was quite fast to implement, and it was RPC, so it's quite easy to reason about. RPC being remote procedure calls, you're just basically calling a method in your system, which looks like any other method, so quite easy to do. One of the cons is obviously as you start calling methods left, right, and center, is you get this explosion of intertwined communication points. So you're just increasing the number of ways in which a service can call out and other services can call in, which obviously creates quite a web and quite a mesh. One of the other cons as well is it's a proprietary service fabric stack. So the service fabric remoting stuff sort of existed and lives inside the service fabric itself. So unless you're a Microsoft engineer, knowing all the different nuances of how the remoting stuff works is a little bit harder to come by. It's not so prolific as something like HTTP. And also another part of it was there's no real clear or definitive interface or spec for this stuff. Like when you look at it, it just looks all very normal code. There's no real sort of outside stuff you can look at to see what the boundaries of the application are. And I'll just quickly take us through an example of SF remoting. So at the top there, we've got some using statements. We're importing the Microsoft Service Fabric platform stuff into our code, which is a little suspect. It's not the most ideal thing to be bringing in platform stuff into your code. Kind of a mix of concerns there, a bit of a code smell. But the rest of it, you can see it's pretty straightforward, right? We create an interface, it's got one method on it, and then we implement that interface, and we inherit from the stateless service. We just implement some of those methods. The hello world async method being the one that you call to get some data from. And obviously there, you can see it's returning something to the caller. And at the bottom there, you see sort of like how a client would interact with said service. There's just a really basic URI there, just quite simple, almost looks like a file path. And then you just await a call to the client of using the method name. And quite honestly, it's quite it's not that obvious about what's going on. You'll be forgiven for thinking it was just another method call in the system if you didn't see the service proxy part. That's only a little giveaway, and obviously if that's hidden behind DI, you're not really going to know. So yeah, there's only a few little signs there that you're actually making a call outside of your system. You could maybe think client, yeah, that's one thing. Async, that could be another. Obviously we're told to do async all the way down at the moment. It may change later, but the fact is very little telling you you're going out of the system. So that just looks like a monolith with extra steps. Yeah, it's starting to, that stuff is creeping into, being a distributed monolith. Something that is just as not ideal as a normal monolith. So, we wanted to tackle that, and one of the first ways we were tackling that was with RESTful HTTP. This is quite an embedded architecture and known pattern throughout the industry. So you've got a lot of good industry knowledge there that you can draw on. And some of the pros about this, just some of the things that highlight of why it's good for us is the fact that there's a lot more upfront thought about it. When you're creating status codes or when you're looking at the unhappy paths, you kind of have to think about what does this do? What does this mean? What should we return? And that little bit of upfront thought and that little bit of upfront design just makes a clearer architecture, makes a clearer bounded context around what you're doing. And obviously one of the main praise about RESTful HTTP is it's cross-platform, cross-language, cross-discipline standard. So it's used everywhere, from TVs to watches to whatever. So it's a pretty prolific standard. And we all know that Java runs on 6 billion devices doesn't necessarily make it good. But it's a standard that keeps progressing, unlike the aforementioned language. But it's something that that keeps progressing and evolving, and new standards are brought out, and new ways of using it are brought out each day. So it's a pretty good place to start from. And obviously around the clear, definitive interface and spec, we've got Swagger, and I think we're all pretty comfortable and know about Swagger, being able to just document your actions on your controllers and document your controllers and that, and just automatically creating this UI where developers can go and play with, fire different requests, see what the responses should be, see what the status codes to be in case you get a status code of something like 400, where you can see what the client can do to rectify that. Really, really focus on creating that clear boundary. There are some cons to HTTP, obviously. Added latency. It's obviously serializing string data across the wire. It's obviously a layer 7 protocol, so it's quite high up on the application stack, and there's going to be a little bit of latency around that. gRPC might be something you can look at there. There's a lot of code bloat, obviously the amount of documentation around all your controllers and your actions. You have 1 billion actions per controller and 1 billion attributes per action. You suddenly got 1 billion by 1 billion amount of lines of documentation, and especially if you use thin controllers, suddenly you're just reading a documentation file, and it's a bit of code bloat. I will note that it looks like there's going to be able to create methods to handle HTTP requests that don't live inside controllers. I've seen that floating around the .NET stuff, so that might be something there. And then obviously it's unidirectional with it's a request response model, basic client server request model, unless obviously you go to HTTP 2.0 and maybe some other protocol on that, something like gRPC. As you can tell, I mentioned gRPC twice, and this is one of the things that having in the company of a technology radar is a good idea, because we can look at these different new technologies such as gRPC, and working as an effective team, bringing in these new technologies to the floor and then discussing them, creating POCs around them, and starting to bring them in gradually, so you can actually identify where the areas are that they're really going to improve your application, and sort of the areas that we need to be mindful of, so that we don't fall back into another situation of having a distributed monolith, or sort of making our lives harder doing something else. So that brings us to our second key takeaway of the presentation. From the technical standpoint, decoupling is still a good idea. Just one thing to note here, with the coupling versus complexity graph, where you've got coupling on the y-axis and complexity on the x. Obviously, as you increase in both, as you increase in one, you increase in the other. So as you get more decoupled, you get more complex. And a lot of the times it's about creating these bounded contexts, creating these boundaries around your services to try and, increase the documentation around this complexity, so you can sort of have a better time trying to understand it and what's happening, and make better calls about where to decouple and how to decouple, and which vertical or horizontal you want to decouple in. Whether it be at the network level, whether it be at the application or code level, or whether it be at the business level. And what a good way to decouple applications are? Events. And that lovely segue brings us nicely into the next part of our core part of our system, which is the eventing system that we use. So initially you started off with these thin events. The pros to this are easy to implement, fast to implement, and less short-term cognitive load. So these thin events that we're talking about, they're more like these notifications that you can fire off. It's like, payment's been received, this has happened, this thing's happened, and they're just little notifications. And the problem with these thin events is you start to increase inter-service communications, because when you fire off a notification to another system, say, payment received, that then system then has to go, right, payment received, I need to go and get that information for that payment. So then has to hydrate the information in that event to be able to carry on processing. And you know, so that means it has to go off and call a database or call a microservice somewhere. And you know, with firing off loads of notifications all over the place, this kind of makes it hard to keep a track of everything that's going on, especially if you've got multiple places firing off the same notifications, or just a proliferation of notifications due to how easy it is to sort of start firing off. You know, I'll just fire one off over here, or I'll just fire one off over here, or I know this would be a good point to fire one off. You know, suddenly you've done that 10, 20 times and in one service, and suddenly all your services are firing off hundreds of thousands of events, and it gets a bit hard to keep track of everything. And then obviously the out of order information side of things, yeah, that goes back to the first point, where when you fire off a notification and you have to hydrate that data, that the system that fires that notification off, it's then got to write that data to a database or a blob storage or wherever. And if that hasn't happened as the event has been fired off, then that service then will find that it can't get that information to rehydrate the event. So you might have to, you know, stick it back on the queue, retry it, and then, you know, suddenly we have to dead letter, and all of that is just noise to the system, and it's not very useful, and it causes a lot of issues and false positives and false negatives and all that kind of stuff. So it's not great. So in order to combat the eventing system and then some of these issues that we're encountering, was by creating an event policy. This event policy is something that exists across our innovation spaces to try and make a consistent way of dealing with events. And to go on the old cooking analogies, if everyone's heard of it, you know, fat means flavor. So we're moving towards a fat events rather than thin events, where all the information required to respond to the event is actually put on the event itself. So rather than relying on the database to store some of that information and rehydrating later, it's all on the event. So as soon as that signaled system picks up that event, it can then continue to process, and it goes, oh yeah, no, I've got all the information I need, don't need to bother going off to any database or anything. So that's better on latency, it's better on processing speed, and it's better on the fact that it's got all the data it needs. And then following on the food analogy, foods for thought around the eventing stuff. You know, how do we reliably raise an event? One part of reliably raising an event is to make sure we're only publishing an event in one place, because obviously the more places you publish a particular event, the harder it is to track back when this event gets raised, where it came from, and if that particular event happened to error somewhere, you got to try and track that back somehow. So you know, it becomes a lot easier when you say an event must be published from only one publisher, something that we do. Then another thing to think about is how do you version the events? You know, breaking changes. Do you start to deprecate certain topics, certain subscription streams as you make breaking changes? You know, what do you do for backward compatibility? You have to make sure that when you add these minor changes, these minor upgrades to the events, you know, make sure it still works with the entire process. And then obviously, how do you make them discoverable and documentable and documented? You know, that's one of the big things of understanding, you know, is this topic still in use? Does anyone still use these events? You know, making sure that we know whose responsibility is for certain events as well, you know, going back to this part of the, you know, ownership and responsibility in teams, and making sure that persists through our events as well. And you know, as we start to talk about, you know, reliability and all that kind of stuff, we ended up starting, you know, our reliable eventing journey at ClearBank, you know, moving from thin events to fat events, and then from fat events being able to start looking at other areas such as idempotency. So just to put a baseline in, idempotency is a property of certain operations in mathematics and computer science, whereby they can be applied multiple times without changing the result beyond the initial application. So to distill down what that means is, say we had an API, you call this API with some data, and then the API, put that in the database, comes back and says, yeah, all good. If you call it again with the same data, the API goes, well, yeah, that data already exists in the database, it's all good. So even though the two operations happened with the same inputs, the same output, and nothing happened beyond the first initial result. Yeah. So that's the core of idempotency. Obviously the opposite of that would be, if the database suddenly had multiple entries and start getting duplication of data, which starts to lead down the path of very bad places. So this is initially actually helped by using the FAT events, and the core driver of this is the FAT events, and being able to say this is a duplicate data, because you have all of the data you need to identify the fact that this has happened before. Without idempotency and reliability, we started to exhibit a few things where we were actually losing events never arrived or existed, and that's bad, especially in a regulated environment. We can't be losing events or losing data. Everything that is made through a payment has to be passed on to any institutions down the road. That's one of the regulatory requirements. So that's very important that we make sure we adhere to that. And also, when retiring some of these messages, it just caused duplicate events and duplicate things to happen, and lots of duplication, which is all the way down the system, which is really bad, really horrible thing to try and deal with. So when we introduce idempotency, we're sort of mixing with the idea of making sure handling each event is atomic. So atomic operations atomicity implies an operation that must be performed entirely or not at all. So being idempotent means you get the same response all the way down the stream. Means even if one of those particular parts failed, the whole of the process still carries on without any horrible side effects, which is quite important. And to be able to obtain all those events, like I say, we need some kind of outbox pattern. Another brilliant segue to the next thing in our reliable eventing journey, the outbox pattern. Its entire purpose is to take an event and make sure that it gets raised on the event bus. And we essentially did this with we essentially did the outbox pattern with Cosmos SQL change feeds. So the idea is we get payment in, we record it straight into the database, the event into the database. That raises a change on the change feed, and then we have this change feed processor which takes that change off of the feed and attempts to publish it into the event bus. If it succeeds, then that change gets marked as handled. If it fails at any point to try and get it on the event bus, then it won't mark the event as the change as handled, and the checkpoint won't move. So there's a little checkpoint marker in there, and it won't move. So it will keep retrying until it can do that. And if it can't, it just raises an exception in the system, and we can look at what's happening there, whether we've got an outage of a queue outage or something like that. But the core part of this is that event is not lost. It still exists, and it's still in the change feed, and it's still there, which is really quite important. Obviously, even if it succeeds but doesn't think it succeeded, putting another event on the bus means that, because of the idempotency, means that it shouldn't have an issue, which is again another really important thing. So this brings us to a third and final takeaway, is events, and FAT means flavor. So in a bite-sized chunk, these events, they should all have all the data they have, and this can drive to some really important reliability and idempotency things in the system. And this still holds true. We're not quite doing an event sourcing system yet. We're definitely moving in that direction. But even for event sourcing systems, having FAT events is still one of the core parts, it's really key, and it requires a little bit of upfront thought and upfront design again, but obviously it leads to much better things down the road. So yeah, I'm going to now hand back over to Alistair to finish the rest of it. Oh wait, no, I'm not. I take that back. I pulled in Alistair too early. What I meant to say was, I'll be remiss to talk about events, but not talk about traceability, and try and palm it off to someone else to finish what I'm supposed to be starting. So traceability is something which is quite key in event system, and you can do this via correlation ID, so being able to try and track the event back through the system to find out, what action caused it and which APIs it went through and what happened. And in the initial implementations for the projects, we wrote this custom piece of code to do that, and make sure that our Service Fabric calls, Service Fabric remoting calls had that information on. And as obviously we've moved away from Service Fabric remoting, moved to HTTP World, we started to migrate more towards this W3C trace context stuff. So I believe that's the .NET activity stuff in .NET Core 3.1. So it's all baked into the framework, which makes it quite easy. So thanks Microsoft, thanks for that. That's really quite useful. Another thing we don't have to think about too hard. And then obviously tests are really important to a system, and making sure that everything happens in the way that we want it to happen. And part of that is, making sure when we raise messages on the event bus that we pick up and deal with in the right way. Tests sometimes just put bad or trash data into an event, and a microservice down the road is going to pick that up and be like, oh, I can't do anything with that, and starts randomly dead lettering, and then you get all these sort of random dead letters happening, and suddenly the system is pinging people going, oh, dead letters are happening, and these are all just a bunch of false positives and false negatives, and you don't really understand whether this is a true thing that's a problem or not. So it's quite an annoying thing to happen. So I'm currently writing a Roslyn analyzer to go through all the solutions to find out whereabouts we could be raising an event on the event bus, and make sure that it's properly, the event's had some metadata added to it to make sure we can identify this as a test message, so that when we go and clear the dead letter queues, we have like the most amount of confidence to say, yeah, we don't have to worry about that. That's just from the test, that's failed. Now I'll pass over to Alistair and not jump the gun. So Alistair, take it away.
Thanks, Callum. So what we want to look at here is kind of where we are now from these current decisions that we've made, and the way that we're kind of currently iterating on what we have at the moment. So from our initial shift, we've looked at the disadvantages, some of the, I don't want to say mistakes, but paths that we wouldn't possibly choose again. And Callum has just talked about, some of these are examples of these ideas. So for one, the kind of no remoting, we want to abolish remoting. This is kind of an instance of how we're constantly trying to iterate on the technology side, or the kind of design side. Learning from what we've done before, and saying that what we want to be looking at is better asynchronous patterns and more distributed patterns, more reliable patterns in that regard, but also continuing to look forward at how could we improve what we have. Could we move towards gRPC instead, take this one step further? On top of that, we don't just want to be iterating on what doesn't go quite so well, but also iterating on what goes well and what worked. So I took us through how our changing the team structure and splitting into domains really helped us accelerate the pace at which we were moving, and helped us to kind of work more reliably. And what we decided we wanted to do was build on this, take it one step further, create an even more mature team structure. And that's gone from having teams owning domains to having, say, a collection of teams within a hive, within a specific domain. And above that, within that hive, having a kind of overarching enablement team, which, while separate teams work on their own individual services and own those and control those, we have a team that is there to support them, to enable their continual advancement, to basically reduce blockers. If something's going wrong, the enablement team can come in and find out what the problem is, and hopefully make it so it won't be a problem for any other team, etc. The eventing policy that we've been talking about is more of an example of iterating entire consistency for the whole organization. I've been talking a lot about team responsibility, making teams more autonomous. But at the same time, we are one organization and we need to move forward together. And what we need for that is clear, defined communication between our services. What we haven't talked about quite so much, which is also a really big thing that we've been working on over the last year or so, is actually taking advantage of some of the really cool sides of the services that Azure, the technologies that Azure provide us on the resiliency side. So that's kind of taking advantage a lot of kind of availability zones and all this resiliency stuff. And this is really important, again, keep coming back to this point, this is really important for how the regulators view us. And this is something that regulators actually really like, is stuff like we have a very hands-off approach to the way that we run our infrastructure, application changes, and access control. So I've mentioned, these automated processes, these automated pipelines. That allows for, these pipelines are in our source control and can be themselves audited and seen, and the regulators can see that. And that allows us, as I've said, to move quickly and change with requirements and change with our clients' needs. What is a little bit more new for dealing with the regulators and has been an interesting discussion point, and that's how we're handling backing up the data, these availability zones, using asynchronous replication across 3 data centers, which is quite far removed from the traditional system in banking with one secondary backup copy, self-hosted. But what we've managed to show and actually demonstrate already is that via using these cloud services, we can maintain payment flows even when we're having some kind of external problem. Through resiliency testing and actually one real world case, we have actually shown that our payments, our transactions will continue to flow, our customers are unaffected. And that's something that we aim to continue to show and actually demonstrate to the regulators, that via using these cloud service providers, by using Azure, we can actually achieve and surpass what you could do on a self-hosted environment. So we wanted to give a quick overview to kind of help visualize how we apply these principles. So we've got a quick look at quite an abstract overview of the rough architecture model that we've currently arrived at ClearBank. And just to point out some quick do's and don'ts. I'm not going to go into too much detail on this. So one of the main do's that we can see here is that we want to separate our domains nice and clear, 2 big separated boxes, and they're not crossing over. And we would have separate teams or a separate hive assigned to each one. They control the services that go into each one. What we don't want, which we can see kind of right in the center with all the big red crosses, is we don't want these domains to be linked via databases, RPC, or even when it comes to events, we don't want direct queues. Okay? Because as we were talking about, we want one publisher and many subscribers, a pub-sub pattern, one source of truth. And that comes into the do, which is what we want is to communicate via APIs, well-documented APIs, and events published on topics. So there's one publisher, and whoever wants to listen to it can subscribe and get the information they need, and all the information that they need should be there. They don't need to go anywhere else. So that's kind of where we are at the moment. But looking back at kind of the whole path, our entire journey to this point, we've seen that it's a journey of kind of iterating on what we have at any given time. Always assessing what you have, seeing how it could be improved. What did you do well? What could you improve? And in that time, we've gone from having a monolithic structure as our first product to a nominally separated, well, monolith again, basically nominally separated services to an actually distributed system, which we have today, more or less. And alongside that, we've iterated through our team processes, our kind of company policies, going from a centralized team to domain separated teams and creating more overarching, understandable documentation for everyone. And in that, trying as much as possible to give control to the people who are closer to the actual inner workings of our services. We don't want some kind of overlord calling down from above. And this leads to kind of a couple of major lessons that we've really learned from this. And these kind of roll together, the key points that we've already mentioned, but one of the first one is teams over code. And it's quite simple that realistically, the code doesn't come from nowhere. It comes from the teams that are writing it. And if you have a good team that works together well and are happy and are in control of what they're producing, then you'll get good code and you'll get good services. Along with that, what we've also kind of learned is that design, well, a little bit of design can go a long way. And obviously we're not talking about going back to some kind of waterfall world, but we're talking about having a design North Star, an ideal goal, or an ideal view of where you would like to end up. And, you know, that isn't a defining state. That goal can be revisited at any point along the line. You know, change it as need be. As new technologies, new ideas come in, adjust to that, see where you can go. But ultimately, what we're trying to avoid in this, when we say this, is we want to separate the idea of the inherent complexity in the problem that we're trying to solve from the accidental complexity that you can inadvertently introduce through the implementation that you've made by just doing what's comfortable. If you do what seems comfortable and the quick fix at the time, you're going to end up maybe regretting it down the line. So bearing that in mind, that's something that we've kind of learned possibly the hard way in some ways. So that just leaves us to kind of where we are today, and we just wanted to share some kind of stats that we're pretty proud of, as ClearBank has kind of grown quite quickly. You know, we've come from a small kind of centralized team. We're now up to 22 teams on the innovation side, with about an average of about 6 people, or roughly about 6 people per team. As we talked about iterating faster, we've gone from around, in 3 years, 16 releases, that's it, to over the last couple of months, averaging 150 releases per month. And this kind of movement and iteration has been visible in the amount of transactions that we've been handling, which is obviously, of a bank, that's the bread and butter. We've gone from handling 2 years ago 2,000 transactions to just last month we were handling over 4 million transactions. And it's that kind of volume growth that we're proud to be able to present. So realistically, that just leaves me with 2 things left to say, and that's one, that ClearBank are still looking for more people. So we'd always love to hear from anyone who's interested, love to hear new ideas, bringing in new expertise. And finally, from Callum and myself, we just want to say thank you for listening to our presentation. And if you have any questions, we'll try and answer them to the best of our ability.
Just going to cut in there and just say, yeah, thank you very much for listening. And I know for me, this is, I've done a couple of tech talks, a few tech talks, and I have some experience around this. But this is, and I think this is one of Alistair's first tech talks that he's given, and he's done an absolutely fantastic job, and he's spoken amazingly and brilliantly, and yeah, very well done, and big up Alistair on this one. Lots of claps and Absolutely, mate. Well done.
Thank you.
And I agree, man. That was really good. So we'll get onto the question side of things. I liked what you said earlier on in the talk, Callum. I liked all the cooking references. You know, fat equals flavour. Funnily enough, that's in my Tinder bio. So, oh God. Yeah, we have had a few questions. If I kind of read backwards from peers. Of course, we were speaking a lot about .NET Core, the most recent version, but Piers was asking, have you migrated into .NET 5? Yeah.
So Service Fabric itself, which is the platform we deploy onto, has only just recently moved to .NET 5. So realistically, in terms of services we're releasing, not quite yet. It's definitely something on the radar though to do, but we got to understand the release process first, because I know the release process around .NET 5 and .NET 6 and the length of time of support as well is something that needs to be looked into. However, on the testing side, so if you're test engineers, yes, I think a lot of our testing is done in .NET 5.0. So yeah, it's definitely on the way.
A lot of the sides of our services which aren't Service Fabric dependent, which is a little few and far between at the moment, most of them I think have been moved towards .NET 5 now.
Cool. Then one just before that, Andrew asks, how do you orchestrate your system where there are so many multiple listening consumers?
How do you orchestrate your system? Might have to get a little bit more detail on that one.
So I guess one of the challenges from an organization I worked at that used events between things is when you publish an event, but in effect there are transactions, there's a series of 5 different systems that listen to that event. How do you make sure they all go off and do their same thing as one thing?
So yeah, you know, we use a mix of monitoring and monitoring tools to have a look at what's going on. We use Service Fabric monitoring, where we have PagerDuty and Dynatrace as well as other tools to help with monitoring. So you know, when we deploy all this stuff, we pay close attention, very, very close attention to what these tools are saying to us in terms of, you know, yeah, what's flying around the system and any issues that come up, any exceptions that get raised. We can either see them in Dynatrace, and then obviously PagerDuty will flag up if anything goes wildly wrong. Okay. But we're looking at building on those monitoring tools as well. That's definitely something in what we're trying to do at the moment, is really focus on reliability and stability, and monitoring tools is something we're really focusing on as well.
Okay, cool. Then the next few questions are still from Andrew. He also asked, have you also considered something like Kafka or event sourcing?
Yeah. So
strong views on that one.
Yeah. So I mean, it's definitely something we're working towards. And I think one of the big things that ClearBank will be doing so well is iterating on everything they've got, and we keep iterating and improving everything that we're doing. And it's definitely something I think is on the horizon. You know, a lot of the eventing policy that we've got sort of has quite a large nod towards event sourcing. Yeah, so I think, you know, it's definitely something that's on the horizon and probably something we might start looking at. But again, you know, we've got quite a lot of services and we've got quite a lot of regulations, so we need to make sure that everything moves correctly in the right way. My personal opinions is like not ClearBank's opinions is if we do look at event sourcing, I hope it's not on Kafka. I hope we maybe look at something else that's a little bit better than Kafka. But yeah, I mean, there's plenty of scope and plenty of design to go into what we could do in that space and how we implement that and how we look at doing that.
Okay, and then yeah, another one from Andrew. I think this is the last one, unless of course anyone else has something on their mind they want to get off their chest. It's quite a broad question here, but if you were starting over with what you know now, what would you do differently? How would you balance time from MVP and purity of DDD design? I'm not sure if those are 2 questions or just one, Andrew.
I think in my opinion, looking at what would we do differently, in the look back section when I was talking about design over comfort sometimes, and saying how we have seen, partly from, I guess, when I was describing it, what might have prompted this question is seeing how looking forward a little bit further, looking at the design initially, instead of just going with the MVP, could have saved us possibly a lot of effort down the line, and maybe having a kind of North Star effect. So at the same time, you do need to, we needed to get something out and working, because we couldn't get to a point where we could scale unless we get our banking license. So you have to be pragmatic, that ultimately the business side, as much as we want to make a beautiful domain driven kind of thing, the business wants something they can show regulators and say, it works, please give us authority to, go further. So it is a bit of a balance, but I think that concept of having a North Star in mind, and then seeing what we've done more recently on some of the projects that I've been working on, because we're starting up quite a new payment scheme in that regard. We have an idea of the design we want to get to, and if it's not viable for the minimum viable product, we're looking at how can we do that for the time being with the intention of making it removable or changeable and adaptable without breaking the other stuff around it. So kind of a compromise there.
Yeah,
Nice.
Yeah, and I think to further what Alice is saying as well, I think there's this like inherent complexity and accidental complexity, and I think, in terms of design over comfort, when you're sitting there making these small changes, you're sort of acting like this speedboat, and you're just changing direction and moving very quickly, and you can start to introduce a lot of accidental complexity in your system, because you think of doing one thing one way, and then maybe later you do it slightly different, and you're just following this zigzag line. And I think there's a lot of inherent complexity in what we're doing, and we want to make sure that at the core we're focusing on solving that kind of stuff. And I think really it's about putting up those, like Alice was saying, those guardrails to say that we operate in this area going in this direction, so we can bounce around inside or whatever, but we're all trying to get go in this particular direction, and trying to minimize the amount of sort of accidental complexity we bring in the system, because I think that is definitely something that, to build on what Alice was saying earlier about, that kind of kills us, when we could have probably saved a few man weeks, and do something slightly different. So yeah.
And we've got one more question, which I can imagine would be quite beneficial for anyone who was thinking about potentially joining in you guys in ClearBank. Grant asks, do engineers drive their own backlog of work items, or is it mostly driven more from a business perspective, or what is the balance like?
So one big thing I know we're driving, and I know we've got Lee on the call, and he might be happy I'm saying this, and one of the things we're driving is that we're trying to look at, it's the team as a holistic thing. We try not to have a separation between what is product, what is the business, what is developers. We try and work as a single team, and we're all there to try and drive the product forward and everything that we do. That means that even refactoring things, being able to bring things up to date, that's all part and parcel of the product, right? That has benefits. That has benefits for the end customer. And I think it's really important that is part of the work as much as new features are part of the work. And I think we try and work as this core single team, and identify the areas where we think we should be doing this or doing that, and pushing those out. And another thing alongside that is, in my opinion, I think, and something I'm trying to drive out with my teams is I want them to tell me what's bad, what's not great, what's not going well, and I'll go and champion that. I'll go and champion that up to the rest of the organization, and and make that a possibility to do things. So want this new technology, right, let's go and have a look at how we can use this new technology. We want to do this particular way, right, let's go and see how we can build that in with the rest of what everyone else is doing. And I think and then also as well, being able to take what other people are doing and implementing it ourselves as well. So yeah, it's really I really think the teams themselves really get to drive quite a lot of what they do and how they do it, how they work, and as long as we always do that with the customer in mind, especially on the delivery side, the delivery teams, as long as we always do that with the customer in mind, I think that's I think it's going to benefit everyone, and you get to work on this stuff. So yeah, I hope that answers it.
Cool. Then just very quick question. Si just asked, are you guys using Scrum?
Yes, yeah, we use we have Scrum, we have Scrum Masters, and yeah, so we've got boards. We use Azure DevOps, as we pointed out on the first slide. We use Azure DevOps. We use Git. We're actually, especially for the banking industry, we're very modern for the rest of the banking industry compared to the rest of the banking industry. But it's a great place to work in terms of that kind of stuff, because we are using new processes and stuff. And yeah, Alistair can definitely talk on that a little bit more, because he's actually in the woods.
I'm a little bit closer maybe to being in one of the dev teams, and we do use Scrum, but at least my experience in the team is that you use Scrum in a way that's beneficial to the team, because different teams work in different ways. So different teams feel they get more benefit out of certain ceremonies from Scrum. And I've always felt like our Scrum Masters adapt the ceremonies for how it works in our team. And you're not just analyzing how you're moving the product forward, but how you're working as a team and how you can improve that.
Okay. Andrew asks, do you do time estimates or story pointing, or some hybrid of the both for your tickets / Jiras?
Yeah, I think we do story pointing. I don't think do we steer away from estimates?
Time estimates we don't do quite so much, but yeah, we do story pointing. And in a sprint, we have, from our metrics from previous sprints, our rough story point velocity for our team. And that kind of guides how much work we might commit to, or say that we might be able to stretch to within a 2-week period.
Yeah, I think there's a little bit of push and pull with this as well, because I think, being in a regulated environment, there are things that the Bank of England, want us to do as being direct participants on the schemes. So, there's things that they're going to be, moving with their schemes, furthering what they're doing, and we then have to then meet that. But they put out what they want and how long, and the sort of roadmap they're looking at to get this stuff implemented, and then we sort of give that as like a this is the broad t-shirt size of the thing. We've got this long to try and do this kind of stuff. How do we then disseminate that back into the teams, and how long does that take in order to get that done? So there is a little bit of push and pull in the fact that sometimes some things are enforced on us, and other times we get to if we're doing stuff for the customer, if we want to add new features for the customer themselves, then we may have a little bit more flexibility around it.
Cool. I think that's it, guys. Yeah, as you guys said, you are very modern as far as bank goes. I think that's what people call being disruptive, I guess, in the banking industry. But yeah, of course, this session has been a pretty good overview of what it's like to work at ClearBank. As Callum mentioned, they are very busy hiring. So as you can see on the screen, those are both the contact information of both these guys. So if this has interested you, then of course get in touch. It's really helpful as someone who's actually recruited in the past for ClearBank. Hearing all this stuff actually makes sense, and not through an interview process. I had no idea what idempotency was, or concurrency, and all that stuff. So it's been really helpful for me, at least, seeing all this stuff on the screen and having it explained. So yeah, thanks guys. You'd probably be interested in doing this talk again in like a year's time and see what's new then, because if this
Absolutely, because I think, you know, this is what we're doing now, and I think, you know, in 8 months' time we could be in a completely different position, and we could, you know, be looking at even the other stuff like the resilience and observability stuff, which I think is something definitely come down the line. And there's just one more thing I want to say, even though I probably talk too much, but just on the ClearBank front, you know, I joined ClearBank as a principal engineer, and it's been a cracking place to work. I've really enjoyed it. You know, the amount of autonomy and responsibility you get given, and, you know, the directions you can set and stuff like that. It's really, you know, it's a really great place to work in that. So yeah, you know, I really do highly recommend it. It's good fun to work here, and it's you get respected, and everyone's so helpful and so nice. You know, I've only met nice people, and it's been a real pleasure so far to work here. So yeah, it's a great place to work for sure.
I guess Alistair probably won't have anything to compare it to, but this was your first proper job in tech, I guess, wasn't it for you? So how's it been for you the last, was it year or 2 years you've been with the company?
So I've been with ClearBank for just over a year now, and, you know, I found it an extremely supportive environment coming in as someone who transitioned career from something completely unrelated, and kind of, I was before this kind of self-taught in coding, just doing a quick boot camp. I found a lot of support that really guided me, and I never felt out of place. And I could always give my own opinions and ask questions. And I've learned a lot over the period that I worked at ClearBank, and it's really kind of stood me in good stead.
Well, it probably goes without saying, seeing as, you know, we're sat here looking at the slides, but I know someone did ask throughout the session, are you going to be able to share these slides so we can put this on the group? Yeah. Okay, cool. And of course, this is being recorded as well. So yeah, this will go up on the YouTube in the next few days. So yeah, thanks to everyone who stayed to the end. That was a really good talk. And of course, kudos, Alistair, that being your first foray into public speaking, you know.
Thank you.
Sweet. All right, cheers, guys. Thanks for coming. And we have in 2 weeks' time a very similar talk with Kodat. See what they're doing in this space. So that'll be quite similar. So that's called the Boring Index, and you'll see that on our meetup page in exactly 2 weeks' time from today. So thanks again, Callum and Alistair, and